need to make an existing tool more LLM-friendly by improving its argument descriptions. You'll see how ArgTransform lets you enhance a tool's documentation without touching the original implementation. We'll take a basic user lookup function and add clear, AI-optimized descriptions for its parameters, ensuring the model understands exactly what format to use. From FastMCP, import FastMCP. From FastMCP Tools, import Tool. From FastMCP Tools Tool Transform, import ArgTransform. MCP equals FastMCP. At MCP, Tool. Def find user, user ID, SDR. Finds a user by their ID. New tool equals tool from tool. Find user. Transform args equals. Userid, ArgTransform. Description equals. The unique identifier for the user. Usually in the format USRXXXXXXX. This demonstrates the tool transformation pattern, a declarative approach to adapting existing functions for AI or RPC consumption without modifying their core implementation. The pattern creates specialized versions of tools by wrapping them with metadata transformations, argument renaming, or behavior modifications. What makes this distinctive is its non-destructive nature. You enhance tools while preserving the original function as a single source of truth. The transformation works through composition rather than inheritance, applying changes as a layer over the base tool. Metadata like descriptions, argument names, and defaults become first-class configuration, while the original function's logic remains untouched. This separation of concerns lets you optimize tools for different contexts, simplifying complex APIs for LLMs, hiding internal parameters, or adding validation without duplicating implementation code. This approach solves the common problem of almost perfect tools that need minor adjustments for specific use cases. Instead of rewriting functions or maintaining parallel implementations, you create context-specific variants that share the same underlying logic. It's particularly valuable when integrating third-party APIs, exposing client libraries as tools, or adapting generic services for domain-specific workflows. The trade-off is a slight indirection cost, but the maintainability benefits outweigh this for most production scenarios. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for defining AI callable tools. It serves as the bridge between your Python functions and the model coordination protocol, enabling tool registration and execution. From FastMCP Tools, import Tool. Imports the tool class from FastMCP's Tools module. This provides the factory methods needed to create and transform AI callable tools from existing functions. From FastMCP Tools Tool Transform, import ArgTransform. This imports ArgTransform, the utility for customizing tool argument schemas. It lets you override descriptions, add validation, or transform values before they reach your function. MCP equals FastMCP. This instantiates the core FastMCP controller, the central orchestrator for all AI callable tools. Without this instance, you can't register or manage tools for AI interaction. At MCP, Tool. Def find user, user ID, SDR. Finds a user by their ID. This decorator registers find user as an AI callable tool in FastMCP. The function signature and docstring automatically generate the tool's schema, including parameter types and descriptions. The ellipsis here is a Python placeholder indicating an incomplete function body. In this context, it signifies that findUser is a stub implementation, with the actual database or API call logic intentionally omitted to focus on the tool registration pattern.
New tool equals tool from tool.
This creates a new tool instance by cloning the existing findUser tool. The from tool class method preserves the original function's logic while allowing argument transformations, enabling customization without rewriting the core implementation.
FindUser.
This passes the original findUser function as the source for tool creation. The tool-from-tool method clones its schema and behavior while allowing argument transformations.
Transform args equals.
Transform args customizes how each argument is presented to AI models. It overrides default behavior to provide richer metadata like descriptions, examples, or validation rules, ensuring the AI understands and uses the parameter correctly.
UserID, ArgTransform.
This applies an ArgTransform to the UserID parameter, customizing its behavior when exposed to AI models. The transform lets you override the default schema, adding AA-specific metadata like descriptions or validation rules without modifying the original function. This pattern keeps your core logic clean while adapting it for AI integration.
Description equals.
This defines a human-readable description for the UserID parameter, which becomes part of the tool's schema. AI models use this to understand the expected format and purpose, improving input validation and user guidance.
The unique identifier for the user.
This defines the human-readable description for the UserID parameter. Clear descriptions improve AI tool usage by guiding the model on valid input formats, reducing errors from malformed requests.
Usually in the format USRXXXXXXX.
This specifies the expected format for the UserID parameter, guiding both developers and AI models. It eliminates ambiguity by defining the exact string pattern, preventing invalid input errors before execution. This closes the ArgTransform configuration block. Required Python syntax to finalize the argument transformation definition for the UserID parameter. This closes the ArgTransform configuration block. Required Python syntax to finalize the argument transformation definition for the UserID parameter. This closing brace terminates the ArgTransform configuration block for the UserID parameter. It finalizes the argument transformation definition, ensuring the description metadata is properly attached to the tool schema before the tool-from-tool call processes it. This closing parenthesis terminates the ArgTransform configuration block, finalizing the argument transformation for the UserID parameter. It ensures the modified tool definition is properly structured before being passed to tool-from-tool. Tool transformation pattern. The ArgTransform class enables precise control over how tools expose their parameters to AI models, allowing renaming, hiding, and default value injection without modifying the original function. Hidden arguments must always have default values, since the LLM can't provide them at runtime. This pattern creates a clean separation between implementation details and AI-facing interfaces.
The argument that vanishes from the schema still answers every call.